We are OpenDetail, and we're focusing on this question of how can we eliminate barriers to lowering the global warming impact of buildings. And obviously we are focusing on the detail to achieve this. So we want to save the planet. This requires experimentation. Experimentation creates risk. Applying new techniques creates a lot of risks. Especially for bio-based materials, which are untested, but this also holds true for trying to reduce concrete in different assemblies. There's many applications, but the starting point was definitely for biodiversity. And this mantra of fail fast is not really palatable within the building industry when you're like when you're betting with people's homes as opposed to betting with venture capital. So we wanted to change that and think about learn fast and how can we make this detailed knowledge both machine and human readable and more accessible more generally. So what knowledge is actually needed in order to reduce these risks? I'm not going to read them all one by one, but in broad strokes, it's an understanding of what is actually built and then what can be approved from building code requirements, connection details, fire risks. There's many types of information. And there are many stakeholders who have a stake in this, right? And yes, it's architects, yes, it's structural engineers, it's fire engineers who have to stamp their names on this, it's insurers, it's investors, it's pension funds. And all of this, the force and the problem intersects at the detail. This is what we need to solve. And if we look at the process for building a database of high quality details, which is the key, we have to capture information. We have to convert that information into something that can be understood by both machines and humans. Store it, make it possible to view, to apply it on projects. And then there's this key loop where you can enrich that information because we know that what we capture is going to be imperfect. And with that, I will say we're going to describe our tech stack. The only thing I want to note before I hand it over to Iman is that we tackled one of the most difficult workflows here, the Revit workflow, but we imagine that this information can be captured from many sources. So it could be Excel, could be PDF, could be a hand drawing that is just entered into the database. And with that, I hand it over to you.
Thank you very much, Alex. So we're just going to go over some of the tech stack that we used and the different stages in which it was used. So firstly, for capture, we're using Revit that's uploaded via Speckle. So Speckle being a very well-known open source solution. And this allows us to be more inclusive in the future. So not just Revit, AutoCAD, Bentley software, etc., etc. And then the next stage is convert. So we used a different part of the Speckle system. So we've uploaded the data to Speckle, and then we're using Speckle Automate, which is their latest feature, to essentially run CI/CD on our building data. And what this allows us to do is to take that information, process it, and then push it to our store. So in the future, what we'd like to be able to do is cut out the need for the user to interact with Speckle at all. So simple drag and drop, and then we have a machine agent of some sort that can convert the information for us and push it to our database, regardless of what type of input the user would like to use. And then for our store, we're using MongoDB to contain both the Speckle information and any other data that we want to store. And because it's a NoSQL database, we can have differing lengths and completely different shapes for our data.
So, and in that storage database, how can we make that detail information machine readable and human readable, right? That's a really key question. It's where we spend a lot of our dialogue, and it's where we benefit from being such a large team with so many different disciplines. And what we just want to highlight in a very simplified high-level way is that part of what we're capturing is the intersection of two elements, because in Revit, things are usually dealt with as a floor and a wall. And the detail is there's actually added information that is unique to the intersection between these elements, and that is part of our data structure. So you can see how that maps at a very low level on the right. But of course, we would address those generic elements, those walls, those floors themselves, and they would also have subcomponents that we could track. Right? So you get a little sense of how that connects. I'll hand it back to Iman.
Yes, so we used a lot of technology in our solution that we built this weekend, and we built a React front-end application, and we used Figma boards to design our UI, which you'll see in a minute. And we also used the .NET Core Web API to communicate between all the different parties. And then gamification is also something that we're looking to implement. So we want to make it fun and interactive for the user, both to upload as well as incentivize people to upload and contribute to the community. And then finally, the apply stage. So we have implemented a PDF export, so you can upload your detail and others can download it as a PDF. And in the future, we'd like to be able to leverage Speckle a bit more, so people can then download it in whichever software that they want to use it in. So download as AutoCAD, Revit, etc., etc. And then now you have the demo.
Yeah, so here's the user interface. There's one of two demos. You can see we're organizing the details by tags, so you can find them specific to the location, specific to cost. There could be any number of tags here, right? There was a lot of different types of information. When you select each individual one, then you get the 3D representation, which comes from the Revit model. We are imagining you could filter this by the elements and the information that's most relevant to you, depending on whether you're an architect, an engineer, a developer. Yeah, I think that it's pretty simple, right? And then if we go to the next demo. Oh, and then here you have the PDF export. Sorry, that's what I intended to mention. You can use it on your project.
So we're going to be bold and try and do a live demo here. So we're going to be very quick about it. But you can see we have, this is the automate function. And we've already uploaded a Revit model previously. And we can trigger the automation. So this will take the model that's been uploaded. Anytime you upload a new model, this will trigger and run automatically and push information straight to our custom database. So you can see success, and then you can see our platform here. And then if we refresh it, we have a new one. And then we can open it. And you can see our new detail, slightly smaller than the one you saw before. And then if I go quickly back to the last slide. So this is the backup. Ignore that. It worked perfectly. And yeah, thank you very much. This is the team.
Also, just wanted to mention that we intend to continue on afterwards, so please get in touch if you're interested in contributing to the project. We have, well, I'll actually leave it to Ashkan.
Yeah, go to the website, the OpenDetail.org/hackathon, and you can find the link. You can go and yeah, continue with us, or if you want to contribute in any way.
Thanks.
Okay, super exciting. Does the 3D view that came up, that was drawn from Speckle, right? You ship it across. Does it map against the specification of any material database or other? I didn't reckon out. Where did you get the thumbnail views on the material?
So, is this working? Yeah. So the whole idea of turning everything from Speckle to another database, so we can leverage what Speckle can offer and turn it into a database that we can use, like something in the future, vector search, where we can assign any material or thumbnails and so on. So and we had a great team working on how we can turn the 3D model, 2D model into an abstraction of this nested data. So later we can recreate this in any form, and at the same time we get to use whatever databases in general can offer in terms of searching or API. We can get connected to APIs and assign materials to it, EPDs and so on. So that is a future, but it was too much for 2 days.
No, yeah, super fine. Because it could also go the other way back, right? So you, or match it up against and say what you've drawn up here does not live up to the XYZ requirements. Super exciting. lot of work in one weekend, I would say.
Great presentation, thank you, and great to hear that you're going to continue. That's really good. How far are you from getting further, going to market? Sort of the big launch?
The project initiated, like we got a first round of funding for this research project, but we didn't know how much longer we can continue with this. That's why we decided to take it to the open community and see how much force we can get. And I hope it's going to be open forever, and I hope everybody can come and contribute to it. And based on, like, I didn't expect to get this much of like talent to the project, and I'm more hopeful than ever to make this even smarter. Like as you mentioned about like connected to like having this mapping both ways, not one way. So it's quite interesting to see like how people, like what people can really bring to the project in the future.
It's also worth mentioning that the Rambøll Foundation has offered some funding to carry it forward through the end of summer.
Oh, cool.
Definitely not.
You're still open.
Can I go back to, in your introduction, you said this was all about reducing risk. And could you elaborate a bit? I mean, I get the library function, the ability to find the information, but how do you imagine that this will help reduce risk if it was up and running tomorrow?
Yeah, I mean, imagine yourself as an architect who wants to use straw on a new facade, or a new type of insulation that is dramatically better for the climate than what's currently on the market, but it's a small player who's producing that material, and they don't have the resources to test it, and they definitely don't have the risk appetite to try it on a new project. If there were a library of solutions that say, okay, this is a problem for moisture in these circumstances, or this is not a problem for moisture if you orient the fibers in such a way, right? It's like the know-how and the approval and like building, like collecting knowledge about the testing rather than leaving it to individual players to solve the solution and bring that to market alone.
Okay, thanks. That's it.